Good. So um, could could wait for like 1 or 2 minutes before we actually start. Are there any questions or anything related that you guys want to ask or communicate? Can feel free to say out loud. How is Monday? Is everyone feeling good? How is everyone enjoying their summer? Good. Yeah. All right. Seems like everyone have a happy summer. Okay. All right. All right. So let's get into today's lecture. So we are talking. We're gonna talk about lecture. We're gonna just briefly review about lecture 9 today. And yeah, yes, yesterday we talked about member variables. You can have a class with address for address, and then you can define a bunch of variable there. So you can see here detail is equal to Toronto, postal code. You can have whatever postal
你刚
code.
刚在喊我吗？
I just searched it up online. Um, yeah, and I have a function called info, and then you can actually print those two. You can actually print those two variables, but the way you print it is a little bit special. Um, you can um, you can actually access those variables using this class instead of using self, because this is sort of like a class variable, right? And yeah, you can also change change this class, change those informations with this class notation, right? So you can call address dot detail, and then you just change that address and postal code, and then after you call it again, then it is changed. Okay, and there is a difference between this and this. What happened is that what we're doing here, it is doing everything in terms of class, changing the class variables, printing out those class variables. But here we have this class record, which this info method is a instance method, and it only deal with those instance variables, right? And then you do RC is equal to record, means build out a new object, and then you print rc.item and then rc.date. Then it will give you yeah, well, this will still give you um, this information in the item, right? And then if you call rc.info, then you can get this info method, and then you'll get this mouse, and then the info method, you get the date, right? And then after you change it here, so record.item equals to keyboard, and then record.date is equal to this. and then when you call our record.info again, then this is also changed. Okay, and here class variable and instance variable. So if you try to assign or update a variable using self dot blah blah blah, then you're defining a new instance variable. You're defining a new instance variable. So you can do some stuff like this. So you can have this item is equal to mouse, and then quantity is to 2000, and then you call this change method with item and quantity, and then you are actually assigning a new variable called self.item. This is a instance variable. It is different than this, but yeah, so you create an instance of inventory, and then you call change, right? And then which is this method, and then you just provide monitor and then quantity, and then you print those out. Then monitor and quantity are updated, but when you try to access those two, inventory item, inventory quantity, those ones are remain the same. Okay, so it still have item is equal to mouse, and then quantity is equal to 2000. Okay, and yeah, if you want to change the class variable, you can do it by this fashion. Inventory the item, and then class variable item, and then inventory the quantity, and then class variable quantity, right? And then you just try to print them out. So and to prove that it is already been changed. Okay, so yesterday we have introduced this. So this is called a property function. What you can do with those property is that you actually make a product a property yourself by calling this method, and then there will be 4 parameters, and then you can use the positional argument. Yeah, remember positional argument, right? So you can just use those. You can provide 0 to 4 parameters, right? And then if you don't provide any parameter, the variable, like the property is not readable, not writable, not deletable, does not have documents. So I don't think there is too much meaning of that. At least something you would do is provide at least one, right? That would make sense. So if you provide one parameter, then you will just have a getter for this property, and then you provide 2, then you will have getter and setter. 3 will give you an extra deleter, and then 4 will provide you the documentation. Okay, so as here we can have a example. Right, so this class rectangle, and then you first define a init function, which is just initialize everything, and then set size. Set size is a setter that just makes a size and then equal to both of the both the width and height. So it is basically a square, right? And then get size, it just returns self.width, self.height, and equal to a tuple. And then delete size, and then break itself, just means it's an instance method, and then it changes the width and height to 0. Right, and then you have this here. So this is the most important one. Size equals to property, get size, set size, delete size, and then you're providing a documentation. Okay, and then After that, you can, then we are sort of in this class, we have defining variable, and that variable has, the output of this property method, right? So this is sort of a property, right? And then you can actually call this property like this, right? You can do rectangle.size, right? And then you just get the documentation. So you just underscore doc. And then you can also do help, right? You can do help rectangle.size, and then or just also print out the documentation that you wrote. Okay. And then rect is equal to rectangle for 3, right? And so this is sort of like initializing a rectangle. And then print rect.size. Print rect.size. When you call rect.size, then what I'm basically saying is that you just called the getter function of the rectangle size for this size property, right? And then just get the this function, what we called, and then sort of just returns you those two numbers, and then as a tuple. So this here for 3, right? And then rect size is just calls the setter instead of the getter, and then just oh, and by the way, the idea is this is different than this, and then you might wondering that why is this not like size comma size. And the reason is that if you call this, right, rectangle size equal to 9 comma 7, it does this packing, right, tuple packing. So it does this tuple packing for you, and then this will then be a tuple, right? And then you are basically doing unpacking here, which is making this tuple and then separate those two numbers into like width and height, right? So that is what happening. And then, I just do print it out, and then you can see 9 and 7 is successfully set there. Okay, and then you can have this delete rectangle size, and then it just deletes the property by calling this del size delete size function, and then just set it to 0, and then once you call it again, then it will be 0, right? So that is a brief review of property, right? So here, what do we have right now? Oh, okay. Yeah. Sometimes you can only have this getter or setter without having lots of extra stuff. You can have u equals to user, and then you just provide the first and last name, and then you can print this u dot full name, right? And then if you do print u dot full name, then it just calls the getter, right? So after it calls the getter, then it returns me this, right? So full name, comma, and then no. First name, comma, last name, right? Yeah. So and then you try to set it. So u dot full name, and then you just it automatically calls the set function, and then since this is a string, then you do a string dot split into a list, right? And then you then assign it to two different variables. One is first, one is last, and then you just assign them, right? And then the last one is just property get full name, set full name. So this is defining a full name property. Okay, then you can just call util print first, print util first, and then print util last, and then it provides you this name. Okay, so now after we introduce the property, then we can have this function decorator, right? We have studied about it on Friday. Then this function decorator has the idea of you can have a def. You can have a function called, for example, state, right? And then this state will just be used as the property name. Okay, as you can see here, c.state, right? So this will be used as a function property name, and then this is also directly a getter for the state, right? So if you use the decorator and then use property, and then you provide a method here, then you will create a property, and then you will just have a getter method already that is bounded to it. Okay, so you can also have a setter. So what you can do is state. So state is the same here, which means this is just a property name, right? So property name dot setter, and then you just define it again, right? With a value. So self comma value, and then if alive. So in value lower, then self.state is alive, then else it is dead. So it's a dead cell. And then, yeah, so that is the setter function. As you can see here, I actually, try to set the state, and then after you print it out, it will say alive, right? And then you can have another property here. This is pretty similar. So it is called isDead. And then when you try to print c.isDead, then it will give you a return. Then it just says self.state lower is equal to alive, and then return not this, right? So this is only a getter. You can set a setter if you want, but in this piece of code, we just decide to make it read only. Okay, so that is the previous one. And then yesterday we also talked about encapsulation, right? And then encapsulation is one of the three pillars in object-oriented programming. And it puts the state information into the object itself, right? And then it does not actually allow outside a function to directly access the information of the inside, right? And it actually goes through the method to actually get those or set those. Okay. And then it just 隐藏了一下其中的实现细节，对吧？然后呢，它让使用者通过实现预定的方式，就是说，我让你get 是什么样的，或者 set 是什么样的，或者 delete 是什么样的，你就得按照我给你的方法去做，而不是你在那边瞎搞，对吧？那么如果你在那边瞎搞的话，比如说，那我对我的东西我就没有控制了，对吧？那我东西万一有泄漏或者出问题，你还要来找我麻烦，对吧？这不太好，不大合理，对吧？那就大家一起用我给你写的方法，然后大家都省心，对不对？So that is encapsulation, right? And it is easy to change, and then raise the maintenance retainability of this code. And then yeah, that's sort of the big idea of encapsulation. Okay, so you can have this this is a large class. You can have a class called user, and then you can have a function called underscore hide. And then in Python, underscore just means it's a hide, it's a private thing that it is private to the class, and it does not want um, people outside of the class access it, right? But yeah, even though there is still techniques to access it, but that is what programmers hope. Um, yeah, and then I can do diff hide and then self, and then you just print something, and then you can have this method called get name, and then you can have this method called set name, and then that is how you define this name property, right? And as you can see here, this is something new. Raise an arrow, right? So raising an arrow just means that when you try to run it, and then the length, in this case, the length is less than 3 or larger than 8, then it will raise a arrow which says, this name length needs to be within, the range 3 to 8, right? And then this is just to, have a validation of the code, right? We were talking about like input validation idea, right? Yeah, and then after that, we just do name equals to property, and then get name and set name, right? And then you can have this, which is similar for set age and get age, right? So, and then you can have this age property, blah, blah, blah. And then after I create this class, if I try to assign this u.name equals to okay, then if I try to run this, then it will give me an error because the name is too short. Okay, so as you can see here, this is how value works. This is how value arrow works, and then name length needs to be 3 to 8. So if you don't provide a specified input, then it will raise an error. Okay, so I am just gonna comment this out, and here, and then as you can see, we can do u.name is equal to Python. That is okay. Age, and that is okay. Then you can print it out, right? And then you can yeah. So that is basically like this encapsulation. It is this idea of getter and setter, right? And then you can have you can define those using this thing called property, right? And then this is the idea. So if you have this hide function, and if you want to call it, then it will not work because it says user object has no attribute underscore hide, but there is no true hiding in Python. So it is just so that the compiler will just add a underscore user in front of method, so you can actually access it using this, right? So you can do just underscore user, and then you can have hide, right? And then it actually calls this method. And then you can also access class variables using this method. You can do print u to underscore user, and then underscore name, and we change it to something else, and then after you print it immediately, then it is changed to something else. Okay, so that is a brief review of yesterday, and then as of today, yeah, yesterday there was no exercises. right? So that is just for you guys to make up a little bit of assignments, and if that was not done, then definitely go ahead and try it. Those assignments are pretty interesting, um, especially when you try to write it yourself. And then yeah, that is the idea. And then as of plans today, we are going to finish class and objects today, and then if there will be time rest, then I would probably show you guys a little bit of idea of like algorithm, which is the next chapter. Next chapter is all about algorithm. Okay, yeah. So if I haven't talked to you guys about this, so yeah, here's the plan. Because this is already July 20th already, so I am gonna spend next few days, probably until the end of this week, um, to finish algorithm, and then we will spend one lecture on topics on computer science, which is sort of a yeah, which is sort of a like research side stuff, or slash maybe presentation or whatever. But just for you to know what is ongoing, very new in the computer science field, and to actually get you guys, having the chance to research and to know what you can apply with this knowledge of computer science, and what you can get out from it, what other people can get outside from it. And then those cutting edge topics, well, one of them will definitely raise your interest, and then you can dig up yourself, even more. And yeah, after that, we will starting our final project. I am hoping to start, next next Tuesday. Yeah, and hopefully we can end it. I don't know, 2 or 3 lectures after, maybe. That's next week's problem. And yeah, so that is the overall plan for this course layout things. We are like sort of halfway or more than halfway through this course. Okay, so yeah, that is what is happening after. All right, so yeah, why don't we start today's lecture? We have yeah, so we have reviewed about yesterday. Today we are going to talk about the next 2 pillars. I would say next 2 pillars in the programming, in the object-oriented programming. This is called inheritance, and in Chinese it's called 继承, right? And then Python 的继承呢是多继承，指的是一个子类，也就是说in English it will be subclass, right? 可以有多个直接父类。多个直接父类呢叫父类叫 superclass， 或者你可以直接说叫 parent class, right? And then we're just gonna use super and super or sub, right? You can call it super class, subclass, or you can call it parent class, child class, right? So that is how we usually call it. Nobody actually calls it father class and son class, so just remember, okay? Even though in Chinese it's called 子类和父类, right? But it's different. Okay, so Um, yeah, the idea of inheritance is that when it just you just take whatever property from the superclass and use it as yours. And this is why it is a superclass, because it is sharing those properties. But often the reason why we want subclass is to want to add more stuff to it, right? Because if the subclass is exactly the same as a superclass, then what's the purpose of subclass, right? So that is one comment that I want to make. So yeah, the syntax, how you define a subclass. So you can have what we usually do to define a class is we directly do class and then space and then class name and then column, right? And then this is just a normal class. And then if you want to do a subclass of a superclass, then you're gonna add a bracket after this class name, right? And then just include every superclass. And then in this case, we have 2 superclass, but you can have as much as you want. But there will be fallbacks on that. We are gonna talk about it later. Ideally, we should only, you know, have one superclass. Normally we only have one superclass. If that is really, really necessary, then okay. If you know what you're doing, then go ahead. Yeah, but normally it is a good thing to keep it as one superclass. Okay, so as I have wrote the comments here, when defining a Python class, if you don't specify what is the superclass of this class, then its superclass will automatically be object class. So as you can see, as you can tell from this, so object is a class, right? And I think it is the superclass for every single thing. Okay, so you can the idea is that if you just do class name, then it will has a superclass called object. Okay, but if you have a subclass that extend, which is inherits a bunch of superclasses, then object is still your superclass, but like it is just one layer that is higher than those superclass. But it still does count as superclass. Okay, so object class will be the superclass of all classes, right? Because either directly or indirectly, right? So if you don't specify anything, then superclass will be a direct superclass. The object class will be a direct superclass. But if you have a subclass that is already inheriting, a bunch of superclass, then the object class will be an indirect superclass, right? Because it is not directly extended from the object class. Okay. So the subclass child class is a special case for superclass. What does that mean? So it means, for example, you have an apple, right? And then you have a class called fruit. So in this case, fruit will be a superclass, and then apple will be a subclass, because apple has every single property that a fruit has, but it has something more. It has something more to it. So that is the scenario when you want to use you know, this subclass and superclass. This means that you know, I am spawning. Yeah, I am spawning from that superclass, which means that I have all the property that that a superclass have, but I have something extra. Okay, so from a child, there we are talking about perspectives. So from child class perspective, the child class extend the superclass. From the superclass perspective, it derives subclass. So what does this mean? So it means extend means inherit. Okay. So yeah, extends just means I have everything of superclass, but I have more. Okay, and the superclass perspective, then you're basically spawning a superclass. You are basically creating a superclass, um, right? Because you know this subclass. I mean subclass. You're basically spawning a subclass because those subclass are actually spawned from the superclass, derived from the superclass that it is has the same properties. Okay, so yeah, that's just a little stuff about perspective. You don't have to be really clear about it, as long as you understand there is a father, then there is a son. Okay, so you will have to do the superclass first before you implement the subclass. Okay, so in this case, let's get into code, right? You can have class fruits, and then you can have this method called def and then info, and then you can and then self. Then I print I am a fruit of blah 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 with how weight, like how heavy the fruit is, right? And then you can have a class food. You can have a class food. You know, can have this the other function called taste, and then it actually prints out a different food has a different taste, right? And then class apple. Apple is a subclass of both two classes, right? It is the subclass for fruit and for food, right? And then even though we do not have anything like any function definition or anything like that, um, a the apple a is equal to apple, so which means I have constructed one instance of the subclass, right? And then if you do a dot weight is equal to 5.6, which appears here, right? It is basically having this self dot weight, right? And then after you have this, then you can actually get or set this property, right? And then you can assign it a dot weight is equal to 5.6. Then you do a dot info and then a dot taste. So you can actually see I am a fruit of 5.6 gram, and then different food has different taste. So that means that whatever you are extending or you inherit from your superclass, you can directly use it, right? And then you can use a dot weight, and then just do something like this. And if you do a dot taste, then it calls the taste function in food. Okay, that is how easy it is. So yeah, in previous code we defined two classes, fruit and food. Then we defined an apple class, extend fruit and food class, and basically it's an empty class, right? But once you construct it, apple object has a method, info and taste, and it has also field weight, right? And then And then one comment that I want to make here is that most of the language only support a single inheritance. So it can only extend, or it can only inherit from one class. And even though Python supports multi-inheritance, which is inherits from multiple classes, it is not recommended to use unless it is necessary, unless you really know what you're doing. And this is because with different class that has same method, it will overwrite the repeated method. And what is this happening? So you can have a class called info item, and then you have a function called info, and then you just do a printing here, right? This is info method. This is an item, right? And then you can also have a product here, product class, and then you will probably have the same method called info, right? It is normal that people use the same function names for to do similar stuff, right? So this is also printing out the info of product. But now, when you're trying to construct a class which is called mouse, and it doesn't actually matter what it's called, but it actually extends those two classes. And then it creates a function. You create an instance using this constructor, and then you call this function called m.info. Then what will happen is only this is called. So item method, this is an item. So only this item method, item.info is called. Okay, and then the reason why is that when we are trying to extend this class, the item is put it in the front instead of product. And yeah, so if you try to do something like this, so product, go to this, item, you go to this, and then if I run this again, then it will call the method in product. But the most key thing is that you are inheriting from two different classes, right? But only one of those class, if they have the same function name, only one of the class can actually, you can actually use, you can only use one of the class, right? And then, so that is problematic. That does not exactly mean that you shouldn't use it, but like just be careful of this thing happening. All right, so like you might imagining that you do m.info, then both of two info method will be called, but in reality there is only one can be called. Okay, so but you can have something like this. So overriding methods from superclass. So what happened is most of the time the subclass needs to add more method than the superclass, for sure, right? It has an extra feature, an extra function or whatever. But sometimes you will also need to overwrite some of the method from the superclass. That means that I have a method, for example, in this case, a fly in the superclass bird. And then I have a class called ostrich. Ostrich, if you guys do not know the English about it, this is 鸵鸟. Okay, and then since it is bird, then you can you have a function called fly, right? And then you just print I can fly, right? But for your ostrich, then you might also have this function fly, but sadly, that an ostrich can only run, right? So what you're doing here is basically override this method, right? So you have this class of bird, and then fly, and then says I can fly, but the ostrich, you only have this method called I can only run, right? And then apparently, if you do a ostrich instance, and then you call this instance fly, what do you get? Right? Will you still get the result from the superclass? No, I don't think so, because I have already overwrite this fly method from this bird class, right? So if you now do os.run, no, os.fly, then it will actually print you a message that is in this ostrich itself, right? So it is overwritten, and then it actually prints I can only run instead of I can fly, right? So that is overriding a method. And then by I mean overwrite. Overwrite needs to happen when this function name is the same. Then it is called overwrite, because you are dealing with the same function, but this function are just how to implement this function the way is already changed, right? But the function itself, in terms of function name, has not changed. Okay. So that is the idea. So after the override, what if the subclass actually wants to call the superclass method? What do we do, right? So like, I sort of have to rewrite this. But, sometimes, the thing you provide me is helpful enough and helpful as well, right? So I sometimes maybe wants to access your stuff. Okay, so now um, now we're going to the following example. So this example here is saying that you have a base class, then you have a definition called you have a function called full, and then you just print full in superclass, right? And then you can have a subclass and then full, and then you just print rewriting superclass full method, and then you can have a function called bar, right? And then you can call self.full, and then you can call base class dot full, and then you need to also provide this parameter called self, because there's I think there is no bounding here anymore, because you're accessing a class that is outside, or maybe it is just because that there is no bounding happening already. It has to do it manually. Like either the case, you are just sort of need to pass in the variable yourself, and then if you by any fortune not pass in, then the IDE will actually remind you that to pass a parameter in there, so it is good. Okay, so this what I'm doing here is you just do subclass is equal to subclass bracket, and then this is just creating an instance. sc.bar just calls the bar function, right? So as you can see here, the output will be executing bar, right? After the executing bar, I go to self.full, which is subclass.full, right? And then it's saying that rewriting superclass full method, right? And then after the read write, what if I want to access the base class, right? So base class, what you can do is do base class dot full, right? And then by calling this class, then it is not that easy to aim at you, right? By calling this class, then you can have this opportunity to call the full, right? So yeah, you also have to pass in this function self, this parameter self, because think, try to ignore it, then you are saying it is saying that missing one required argument, right? So do this, then you can do superclass. Okay. All right. So this is function overrides, and there will be one special case that and that is for constructor, right? And then without further introduction, let us jump right into the code, and then you will know what is happening. Okay, so this section, this tiny section is called use super function to call the constructor of the superclass. So I have a class called employee, and I have a init function, which is salary, right? And then you can have a function called work, and then it just says print a normal parameter. A programmer is writing code, salary is blah, and then you just pass in this self salary, right? And then that is normal. The second class is called customer, right? And when you're trying to init a customer, you're passing, for example, what is your favorite item, right? And what is the address? So you can have a function info, and then you're just printing I am a customer, my hobby is blah blah blah, and then the address. So this is the structure of those two functions, those two classes, right? And then you have a class manager that extends those two class, and then basically in there it does not have anything. It does not have anything. Okay, so what you can do here is do m equals to manager, and then you're just passing like 25,000. Okay, so that is pretty high salary, 25,000. Okay, and then you call m.work. What you can see here is okay, I can access this work function. You actually go ahead and print out normal programmer is writing code, salary is 25,000. But what happens if you do m.info? So m.info is just the second function, here, right? The function in the customer class, right? But if you call m.info, then it will give you an error because manager object has no attribute favorite. And if you try to understand this error code, this is basically saying that you don't have a field called favorite. You also don't have a field called address. When we are constructing it, all we are passing in is a salary, right? And that is why this does not work, right? And then if you try to flip the order of this class definition, so remember here, we put employee in the front and customer at the end, right? And then here you will put the customer in the front and then employee in the end. And then right now you can do m.manager, and then you can do LOL, and then you can do Toronto, blah, blah, blah. And then you can actually create a manager. You can call this method info. Now I am a customer, my hobby is LOL, and the address Toronto. But when you try to call this, right? If you want to try to call m.work, then it has no attribute salary. Okay, so this is again sort of like one. It is either or, right? And then you have to make a choice here. It seems that, but there is one method called super, and then you sort of need to overwrite. You sort of need to overwrite this function definition. So not function definition, the constructor, so that it's it can be you can have both of the constructors, and then right now you will have this manager class, right? And then employee, and then customer, right? And then you're just sort of rewriting this this init function, and then you do self, salary, favorite address, favorite and address. So that is all it takes, right? All three parameters. And then it just sort of prints out manager constructor. That is, we already know. Super. What does super mean? Super just means access this function, this class, right? When you only have one class, then super automatically points to this, right? Points to, in this case, is employee. But when you have multiple classes, then it will just points to the first class, right? And then you will call those superclass constructors using this fashion, and then you can actually provide this salary here, right? So you just call super.init, and then you pass in salary, and then you do customer.emit, and then you also put self, and then you also put favorite, and then you put address, right? Imagine what you can if you delete this self, then it will be problematic. So yeah, so don't forget to add this self here. But like if you have this super, then I'm assuming that this parameter is carried, so you don't have to pass in self. But in here, because you're calling this class, then you sort of needs to pass in self. But yeah, if you don't pass in self, the IDE will remind you, so that is okay. But yeah, and then you're basically printing, providing those three parameters, and then you call work, and then you call info. Then you can now successfully call both of those methods. Okay, so yeah, as of for now, I will call a 5-minute break because I actually want to go to the washroom. But yeah, you guys can review the idea of inheritance, and I review the use of superclass. Okay, I will be right back. I will be continuing in 11:10. Okay. All right, I'm back. Sorry about that. Yeah, so um, yeah, before the break, we talked about this super method, and then it is basically when you are inheriting between like different different superclass, or maybe if you want if you're inheriting from one superclass but like you want to construct more things than this superclass, then you will need this technique, right? So you're basically saying that I take whatever variable that I need, right? And then for those of constructors that a superclass need, I just pass in what it needs, right? And then I can deal with it after, right? Imagine there is like one more variable called like name, right? And then you just do self name equals name, right? And then you just pass in um, like whatever, right? And then you sort of do print name, right? And then you can do something like this, right? So it doesn't necessarily have to be like this. So like if you want to add something extra, just goes on and on, right? And if you want to add like age or blah 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 whatever, right? You can just continue and continue and continue, right? And then you just call this superclass constructor, and then you just do the superclass constructor. If you have more than one class, then you just call customer like the class dot init, and then for those cases, don't forget to pass in self, and then you can do a normal constructor here where you can also set other kind of stuff. Okay, get it? So that is how to use this super, and then what do you want to do when you have, multiple inits, or like, a big init, big constructor. Okay, so the next thing we're talking about is this idea of this thing called slots, right? When you add when you want to add a method to a object, right? We talked about it. I don't know, last week maybe. Yeah, I think we talked about it last week. What we mentioned in previous lecture is you use method type, right? This method type function actually bounds this function, after you define this class, and then you don't have to pass in self. So that is what method type function does, right? But what if you want to add a method to all the instances, uh, right? When you have like a lot of instances, then sometimes you don't want to add it all by yourself because it could be a lot, right? It could be a lot to write. So what you can do here is you just do this. So cat.walk, right? You can have a cat. So you just do a class, right? You call class.walk. This is just a function definition sort of stuff, and then you just pass in walk underscore function, right? And then this self, and then self not name, and then after that you can directly call d1.walk, d2.walk, then it is actually printed out there. Okay, so when you just do class dot that variable class dot a variable, and then you assign it with a function that you defined, yourself after the class definition, and then you can still add this class. You can still add this function to each instance of that class. Okay, so that is more advanced stuff. And then here is a thing called slots. Okay, what slots means is that previously you can sort of define a bunch of I don't know, I would say variables or dictionaries or whatever, and then it sort of define something like this, and then you define it using a tuple. Okay, after you define this, then you can do from types import method type, and then you can do d.walk, right? And then it is sort of like a predefined slots, right? That like you're already defining slots for walk, you already define a slots for age, you already define a slots for name. Then after this class definition, then you can slowly fill in those slots, right? Like you can just fill in those slots by doing like this. So d.walk is equal to method type, and then this is just a lambda function for this walk function, right? And then this d here is just the object you want to pass in, so that it can create the bond. Okay, and then after you do this, then you can easily do like method type, right? And then you can directly call d.age is equal to 5, right? And then you can do d.walk. You can call this function. But if you don't have this, you can see d.full is equal to 30, and then it says dog has no attribute full, right? Like when you want to add some attributes, but you don't know yet what those attributes are, or like what those functions are, then you can define it using slots. So basically you're saying that you initialize it, you create those three stuff as a placeholder, right? But not actually passing in anything. And then you can define it later easily. But if it is not in there, then there will be difficulty of you to define it after, or add in property after. Okay, so that is what slots does. Okay, that is what slots does. And there is no the slots property will not the slots property will not affect method definition using class. It will only affect using an instance. Okay, as you can see here, this is an instance. The instance D, the D is an instance, right? And but if you do class, right? You have a class you can have a class dog, and then you do class dog bar, and then you can just pass in a random function, right? And then you just do d.bar, and then yeah, it actually prints out whatever it needs to print it out, right? So it means that there is no restrictions on it. But yeah, if you guys want to compare, then d.bar is equal to for example method type this, and then d.bar, right? Dog attribute yeah, it is read only. But if I comment this out And then, yeah, I want to restart runtime and rerun all, because you know, if I have run it, then it is already in the memory. But yeah, it says dog has no attribute bar, right? So this is the same as d.4 is equal to 0, equal to 30, but like it gives me an arrow. This arrow is exactly the same as this arrow, like it has the same idea, okay? But it will not affect anything about you creating this using a function. Oops, using a class. Okay, so yeah. Well, what the hell? Okay, yeah, this is sort of like a comment or whatever. So I just delete it and then run it. Okay, so ABC. So that is d.bar. And then there is another idea. So slots only affect the current class. What does that mean? It means that if you have a subclass of dog here, so this class is dog, right? It has slots, 3 slots. But if you have this, if you have a gun dog, yeah, sure, gun dog, why not? So if you have a gun dog that is inheriting from dog, then you know, you can have this def in it, and then you just call this super in it, right? So just have the constructor from the super, and then everything else you can do pass, right? But if you do if you try to assign a variable, it works. So gd.speed is equal to 99, and then you just print out gd.speed, then it actually gives you 99, right? It does not give you any kind of error, so that is good, right? Yeah. So that means slot only affect the current class instead of the inheritance class. Okay, and you can define a class using type. So this is something new. We have used this type function a lot, right? And then this is just to get you to print out, for example, a type of a specific thing, right? You can print out a type int, you can print out a type string or whatever, right? And but look at this code. So you have a class called row, and it does not actually have anything in it. You can have r equals to row, and then it just constructs an instance, right? And then you printf type of r, then it will definitely be just type of row, right? But if you try to print out type of row, it is actually a type called type. Okay, but like this is weird to talk because it has a type of type, but yeah, the class row has a type of type. What happened is when the program is defining row using class keyword, it treated as defining a object with the type of type, right? And assign that to this variable row. Okay, in reality, Python allows user to define a row with a type object. Okay, so as you can see here, you have a function, which is called function for now, and then you know, printf in a function, and then you can have this dog equal to type, and then you use a single quotes to do dog, and then this is what is inheriting from, right? And then so as we have talked about it, every kind of class, if it does not inherit anything, it is automatically inheriting this object class, right? So yeah, this is automatically inheriting the object class. And then, this is a tuple, right? Because Python supports multi-inheritance, then you have to use tuple to identify what are the superclass of this class. And since here we have only one object, we have only one superclass, right? But as I have mentioned above about tuple, if you have only one item or one object in the tuple, and you actually want to make a tuple, then you will have to add a comma, right? So to indicate that this is a tuple instead of like this is just a two brackets, right? And then you can sort of have a dictionary, right? This dictionary is sort of a dictionary for the class variables and functions, right? And then you can have a field called walk, and then you just pass in this function, right? And then you can have another field called age, and then you just do age is equal to 6. Okay, then after defining this, then we can just treat it as a normal object, right? You can do d is equal to dog, right? And then you do type d, you do type dog, and then that will give you a type of type. Then you do d dot walk, then yeah, and actually calls the walk function, even though it does say function fn function. But yeah, you can also print dog.age, then it will give you 6. Those are different ways of accessing this variables, so that it just makes you know that this class is constructed as normal. Okay, so that is everything about inheritance. Okay, that is something big. All right. So we finished inheritance. Now we are going to another pillar called polymorphism. And what does that mean, polymorphism? And I think you guys have seen this that video, right? A video that I show you on Friday, right? So polymorphism, poly means multiple, right? Means 多, right? Morphism means like state or I would say state, right? And then now what does that mean? So it actually means that when the object changes, calling the same method give you a different result. That is, I defined it. I defined it to help you guys to understand it. But there's yeah. But like if you need more official definition, then go ahead and do research on yourself. I believe that is very easy. Okay. So, but yeah, my interpretation is that when the object changes, calling the same method, you have the same method name, but you have different outcome. So what happened here is, say class bird, right? I can have a function called move, and then self, and then field. Field is whatever I am moving on. So you can do print bird is flying freely upon whatever field that is flying upon. Okay, then you can have another class called dog, right? And then dog actually has this function move as well, right? What its function is move, and then you do self field, right? And after you have this field, and you have a different print function, right? Dog is running freely upon whatever field it is. So you will then assign, construct a bird instance. You give it to x, right? And then you'll do x bracket move, and then in the sky, right? And then after you do that, then it will be printed. So let me run this cell. Yeah, bird is flying freely upon sky, and then after you change it to bird, after you change it to dog, then you will do x.move, and then you do x.move, and it moves on the grass. Then it says dog is running freely upon grass, and this is what happened. So after you change this x.move, then after you change this object, sorry about that. After you change this instance, right? You call this exactly the same method, x.move and x.move, and then provide different arguments, and it actually gives you different outcome. So that is polymorphism, and then yeah, that is the idea. And then you might think that for now this is not quite useful, or like, and this is not yet, it seems to be a very useful idea. The following example will give you a better understanding. So you have this thing called class canvas, and then you have this def create draw picture, right? And then you do self, and then bracket shape. Shape is a parameter that you want that you need to pass into call this function, and then you do print starting to draw, and then you do shape dot draw, and then self. Okay, and then that is the function that we want to talk about it at the end. Okay, and then you have class rectangle, right? You have a draw function in class rectangle, and then you will need to pass in self, and then you need to pass in canvas, right? And then you're just doing like printing rectangle on the whatever canvas. Right, and then you would do a class triangle. Those are similar. I just copy paste, but it has different. It is drawing a triangle, right, instead of a rectangle. And then you might also have another class drawing a circle instead of a triangle or a rectangle, right? And then you will have this class canvas, which actually interacts with those three classes. And we will see what is happening. So C equals to canvas. So it basically constructs the canvas object. And then I call C.draw picture, right? What happened is after you call draw picture, then you would have you will need to pass in the parameters, right? And then you will do C.draw picture, and then what is this? So this is basically constructing a rectangle argument, a rectangle instance, right? And pass that as the argument for shape. Did you understand what is going on here? So because when you call a class and then with bracket on it, then it gives an instance, right? The return of this expression is a instance of that object, right? And then you are then passing this instance as this variable shape, in this variable shape, right? And then right now this variable shape is an instance. And then let me run this. Yeah, so this variable shape is an instance, and then you just call starting to draw, and then this is basically saying that that instance call that draw method in this instance. What is the instance here? So for the first sentence, the instance is rectangle, right? So then it will go to the draw function for the rectangle, and then it actually print drawing rectangle on S. Right, starting to draw, and then you do drawing rectangle on this canvas object, right? And then when you can do another function like this: c.draw a picture, and then draw a rectangle, triangle, and then it actually does the same thing, and then goes up here, and then pass in this rectangle instance as shape, and then do that instance dot draw, and then you just draw whatever else, whatever it is. And this self, I actually want to mention that this instance, this self is here, means this instance self. This canvas is actually this self. So do you get what I'm saying? So when you call self in canvas, it is an instance of canvas, right? And then because this shape.draw, this shape is already an instance, so this self will bound to this instance, which is the caller of this function, right? And then the parameter that you're actually passing in is canvas, right? Because in this scenario, self is an object for canvas, is an instance for canvas, right? And then you pass it in here, then it goes to this variable called canvas, right? And then you can just access it there. Okay, so I hope that this has been pretty clear. And then after you just go ahead and do those three, then you can get the results. Okay, so that is polymorphism. And there's another thing. So type. After we have known this so far about object-oriented programming, this is a good thing to use, a good tool to use, and I think it is a built-in function of Python. So is subclass means that it checks if one class is the subclass of another class, right? And then is instance. We have used it before. We should be pretty familiar to it by now. Is instance just means that checks if an object is an instance of a class, right? So there is a difference. So is subclass means it is comparison between different classes, but is instance just needs an instance and a class. Okay, so as you can see here, I have an example. It says hello is equal to a string hello, right? And then if I print is instance hello string, what do I have as the output, right? We will definitely have this output true, right? Because hello is definitely a string, right? Because it has double quotes around it. Is string an object? I would say yes, right? A string is definitely a object. Is a string a subclass of object? I mean, for sure, everything is a subclass of object. So that is a guaranteed yes. Like it is either direct or indirect, but it seems like it doesn't matter. It doesn't have to be a direct a subclass or superclass, right? And then the fourth one is instance hello and then tuple, right? And then just check if the string is a tuple. Of course, no, right? Is a string a subclass of tuple? Of course, no. Okay, so that is this. And then yeah, I just did a line break. So yeah, true, 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 false, false, right? So this above 3 is true. The bottom 2 are false. Okay. And then we're just, since we finished the list, the string, then we sort of just want to check the list, right? And then you can do print as instance my list, and then comma list, and it just checks if this list is a list. Of course, yes, because it is called a list. All right. Is that an instance of a object? For sure. It is a subclass of the object. It is an instance of that subclass of the object. So it is an instance of object. So that is for sure. Print is subclass. Well, list is the object subclass of the object. Everything is a subclass of the object. Is instance my list a tuple? No, that is definitely not a tuple. You can tell that by a square bracket or round bracket. And then is list a tuple, or is list a subclass of tuple? No, I don't believe so, because there is a fundamental difference between them. So yeah, that is instance. And then bases and subclasses. Okay, so bases and subclasses. So you have, for example, you have class A. It doesn't have anything in it. Class B is the same. Class C extends class A and class B. Okay, and then if I call bases, then it gets this sort of I would say direct superclass of itself, right? It's sort of saying that oh, it is, but yeah, direct superclass. Okay, so it is in a tuple. It is a tuple of types, right? And then you can also do this. So you can print a subclasses, and then in this case, we do actually need a bracket here instead of just calling the property, right? So subclasses and then B subclasses, both A and B have a subclass of C. Okay, so that is everything that I want to talk about in terms of object-oriented programming. Okay, so we are sort of finished this object-oriented programming idea today, and then tomorrow we are going to start about algorithm, and then first thing will always be sorting, because sorting is just one of the basic ones of algorithm. Okay, so yeah, look forward tomorrow's lecture. And yeah, before I end, we have 15 minutes left. So I will briefly introduce you guys this exercise, and then I will maybe search up a video of one of the sorting, one of the funny sorting videos, so that you guys can get interested and get excited. Okay, so here, the first exercise, that one is a trivial one. Write a student class with name, age, gender, phone, address, email. Build a constructor for a student class with all fields above, and provides instance method such as eat, drink, play, sleep. Okay, like in terms of method, you only have to do like a print, right? That is good enough. Okay, and then those fields are just not too difficult. Okay, the second exercise: create a vehicle class with max speed and mile, age, instance attributes. Yeah, that is actually continued from Fridays, right? Friday's exercise. Okay, that is continued from Friday's exercise. And create a child class bus that will inherit all variables and methods from the vehicle class. So that is not too difficult. And then create a bus child class that inherits from the vehicle class. The default fare charge of any vehicle is seating capacity times 100. If vehicle is bus, instance, we need to add an extra 10% on full fare as a maintenance charge. So the total fare of a bus instance will become the final amount. Total fare plus 10% of total fare. So 110% total fare. Okay, so yeah. That is this exercise, and then note that bus seating capacity is 50. The final amount should be 5,500, and you need to override the fare method of a vehicle class in the bus class. So what you're gonna do is that create a vehicle class, create a bus class, extend it from video, and then create a fare method for both not video, vehicle, sorry about that. Create a fare method for vehicle and a bus, and then override the bus the fare method of the bus. Okay, so the last question is create a time class and initialize it with hours and minutes. Okay, and then make a method add time, which would take two time object and add them, e.g. So it's 2 hours and 15 minutes plus 1 hour and 20 minutes give you 4 hours and 10 minutes. Okay, and then you will also need to make a method display time, which should print a name, print the time, and then make a method display minute, which should display the local time in the time. So for example, local minutes in time. So for example, you have 1 hour and 2 minutes, then it will just display 62 minutes. Okay, so these are 3 exercises that I leave for you guys to practice. I will talk about it tomorrow for sure. And then you guys can expect a assignment for class or for object either tomorrow or the day after, and then you will have let me think. You'll have the weekend to finish it. I will make the design, make the deadline September. Not September. Sunday night. Okay, so that is what I'm planning to do, and then YouTube. sorting bubble. Yes. Okay, I will give you a video to get you guys, oops. Yeah, so just to get you guys, excited, or, just to get more familiar with the idea, I am gonna decide to play a video. This is funny. Uh, this is a dance to illustrate how sorting is being done. Okay, and then yeah. So without further ado, just enjoy it. Okay, and this sorting algorithm is called bubble sort, and you will understand what is happening after you watch the video. So that was that was just a part of dance. So this is when the sorting actually started. So yeah, keep watching those. Yeah, just be careful with this part. So let's say you have to read an incredibly long. Yeah. So oops. Yeah, that is the video that I wanted to show you guys. That sword is called Bubble Sword, and I don't know if you guys have understand the video or not. If you did understand it, good. If you didn't, it is okay. Do you want to search it yourself, or do you want to take a look at actually what the actual algorithm look like, or do you want to just rewatch the video again to see what is actually happening? I mean, anyways, yeah. So if you guys have questions, I will definitely talk about it tomorrow. About this algorithms, and yeah, here is that is the end of this lecture today. So if there are any kind of questions, I will just give you guys 2 minutes. Any questions or any concerns, any comments, any good thing or bad thing you want to share, just speak it out loud. Or if there is nothing, then okay. Anything that you guys want to share? Any comments that we want to make before we close today's lecture? Yes, no, blah, blah, blah. Okay, no? All right, sure. Then, all right, I will close today's lecture and I will see you tomorrow and maybe look forward to the assignments. All right, sure. All right, thanks for coming, and I will see you guys tomorrow.
Thank you. Bye.
Bye.